Hello students, in the last class in organic reaction mechanisms, the fundamental concepts, we are discussing about the electronic displacements. We already completed the first electronic effect, that is inductive effect. Today let me continue the second one, that is electromeric effect. To understand what is electromeric effect and what are the different types of electromeric effect here, and depending on the nature of the attacking reagent, we can expect the two types of displacements here. Now before I tell you the definition, I'll give the example. Consider a molecule of an aldehyde like acetaldehyde CH3CHO. Okay, you heard about the different functional groups. If CHO group is there, it is an aldehyde group. It is a acetaldehyde in common system of nomenclature, and in IUPAC system there are two carbon atoms, so it comes eth as a root word. An between the carbon atoms there is a single bond, and the secondary suffix comes al, so ethanol. If it is attacked by a reagent like a cyanide, Cn minus, you will understand where the Cn minus will attack. It will attack to the carbon atom. So I told you earlier, in the reaction mechanism what happens, there is a displacement of electrons which results in the breaking of bond as well as a formation of new covalent bonds. So now this Cn minus, I told you basically the negatively charged species, it is a nucleophile. It will attack to the carbon atom. When it attacks to the carbon atom, it will form a new bond. And during the formation of the bond, carbon can be pentavalent. So the shift of electrons takes place away from that. So the product formed will be, this is CH3 remains same. The carbon will be there. And cyanide is a new bond formed now with the carbon. And the hydrogen remains same. Since the double bond pi electrons shifted towards oxygen atom, it will become single bond oxygen minus. So here the displacement of pi electrons taking place away from the attacking reagent. Okay, I'll give you one more example. Let me take up alkene CH3 CH double bond CH2. You know, 3 carbon atoms, there is a double bond, propene. If it is attacked by H plus, now the H plus will attack to the central carbon atom only, and if it is attacking to the central carbon atom, it becomes CH2, or it can attack to the terminal carbon atom, but where it attacks and finally how the stability will be there. So during the formation of the stable product, now if H plus attacks to the central carbon atom, it will become CH2, okay, and the electrons getting shifted over. And during the shift of electron, so you can understand it is a propene attacked by H plus, okay, you will come across Markovnikov's rule, anti-Markovnikov's rule, all those things, okay. Now here what happens is the shift of electron takes place in such a way, suppose if this H plus attacks to this carbon atom, say for example if it attacks here, then what will happen is the CH3 will remain same, okay, so valency got satisfied already. And now if H plus attacking here, this will become CH2. The CH will have a one more hydrogen atom which I'll show as a bond. Okay. Now from where that electrons came from? Because the H plus is attacking species which is not having extra electrons, and if it needs electrons for the bond formation, that is taken from the pi electrons of the double bond only. So it will become CH and H, and now it will become single bond due to the shift of that electron. Okay. So that is anyhow CH2. And it will remain CH2 only, okay. It is unstable, and due to the loss of that electron, it may have a slight positive charge. So in both these reactions, we are not getting a stable product. It is a reaction intermediates only, but we have to understand, due to the presence of a negatively charged species or due to the presence of positively charged species in the second reaction, there was a displacement of pi electrons, okay. Electrons ಎಲ್ಲಿಂದ displace ಆಗಿದೆ double bond ಇಂದ. Double bond ಅಲ್ಲಿ ಏನಿದೆ pi electrons ಇದೆ. So remember, in the previous inductive effect we studied, there was a shift of sigma electrons, the shared pair of electrons of a single bond. Now the shift of electron takes place from a double bond or sometimes triple bond, means in general we say in triple bond, or double bond means multiple bonds, that is a shift of pi electrons. So try to understand comparatively. Inductive effect is a permanent effect, whereas this electromeric effect is a temporary effect. it will happen only in the presence of attacking reagent. If you remove that attacking reagent, then the reaction is reversible, means the displacement will come back again to the same position. So remember now the definition. After understanding these two examples, try to understand what is electromeric effect, and then we'll understand the two types of electromeric effect taking the same two examples. Okay, so electromeric effect is a temporary effect in which there is a shift of pi electrons from a multiple bond towards one of the atoms. Okay, like this case you can understand it may be towards the attacking reagent, or it may be away from the attacking reagent towards one of the bonded atoms in the presence of attacking reagent. Are you clear? I am not writing a definition here, but try to understand. It is a temporary effect in which there is a shift of pi electrons from a multiple bond towards one of the bonded atoms in the presence of attacking reagent. Now we will ask, what is attacking reagent? You understood earlier, nucleophile, electrophile, free radical, carbocation, carbanion, all these are attacking species. The unstable species, they are attacking reagents. So in the presence of attacking reagent, the electromeric effect is observed. Okay, so let me say the definition for the last time, then you try to understand the examples here. It is a temporary effect in which there is a shift of pi electrons from a multiple bond towards one of the bonded atoms in the presence of attacking reagent. Okay, now similar to that of inductive effect, here also there are two types of electromeric effects. Okay, and the two types are, the first one is a negative electromeric effect, and the second one positive electromeric effect. Generally we represented as minus E and plus E effect. Okay, negative electromeric effect and positive electromeric effect. Try to understand from this. See, when the attacking reagent is negatively charged, like cyanide ion what I wrote, when it attacks to a carbon atom, see the direction of the displacement. The pi electrons are moving away from the attacking reagent. Okay, so Cn minus attacking to this carbon atom, and the shift of electrons takes place in the opposite direction. So we can say in the negative electromeric effect, the displacement of pi electrons takes place away from the attacking reagent. So the first example, cyanide ion attacking to an aldehyde forming some intermediate, this is an example for negative electromeric effect or minus E effect. Now coming to the second type, the attacking reagent is positively charged, and when it attacks to one of the carbon atoms here, see the displacement of pi electrons. The pi electrons of the double bond are displacing towards the attacking reagent. So in positive electromeric effect, the displacement of pi electrons takes place towards the attacking reagent. Okay, away from attacking reagent are the negative electromeric effect, towards the attacking reagent means it is a positive electromeric effect. Are you clear? So with this we understood what is electromeric effect and what are the two types. Generally electromeric effect happens in the presence of multiple bond. Try to understand what are the important criteria for an organic molecule to exhibit electromeric effect. I told you displacement of pi electrons from multiple bonds. So multiple bond is required. Second thing, attacking reagent is required. Maybe any of the charged species we consider it as attacking reagent. So attacking reagent is required. And third important thing you remember, comparatively from other electronic effects, it is a temporary effect. So only in the presence of attacking reagent the displacement happened, and as soon as you can reverse the reaction, means we can remove that attacked species so that the original reactant will get back. So it is a temporary effect. Okay, so that's all about the electromeric effect. Are you clear? Yes. Now we'll move on to the next one, that is a resonance effect, also called mesomeric effect. I told you electromeric effect till now. Now we try to understand about the next one, that is a resonance effect, also called mesomeric effect. Here also similar to the previous two, we have to understand what is that particular effect and which type of electrons are displacing, what are the factors contributing to that, and finally what are the two types of resonance effect you have to understand. Okay, so before I tell you about a resonance effect, let me ask you one small question. See, you all heard about aromatic compounds like benzene. I can write a benzene in a different way, the hexagonal ring with the 3 double bonds in the alternate positions. You studied it in the lower classes. I can write a benzene in one more way, that I can write benzene with a different position of the double bond. This one also I can write as benzene. Okay, I can write a benzene in a one more way, where I'll write a hexagonal ring and I'll write a circle inside that. Okay, and the last one, the one more possibility, I can write a benzene with a hexagonal ring and a dotted circle inside this. Okay, now my question to you, which is the correct form of benzene? You say all four are correct. Okay, now why there is a more than one structure for benzene we can write? You know, the double bond what we represent inside the cyclic structure there, it stands for the pi electrons. And in case of benzene, the pi electrons are delocalized, okay, and we can say it is a resonance structures of benzene. Okay, so you study that a little in the hydrocarbons later, but the resonance structures of benzene is possible because of the displacement of the pi electrons. Okay, so now with that you understood resonance structures are possible, or resonance effect is happening due to the displacement of pi electrons. Now the one more question is, suppose if there is some other substituents attached to the benzene ring, maybe having a lone pair of electrons. I told you yesterday, the lone pair of electrons are the usually non-bonding electrons. In the presence of the lone pair of electrons also, there is a resonance effect. So now try to understand, for an organic molecule to exhibit resonance effect, the electrons required is a pi electrons and the lone pair of electrons. And one more important thing, it requires a alternate single and double bonds. The conjugate system we say. Okay, so conjugate system is a one where there is a alternate single and double bonds. Okay, so this is just a rough idea to tell you about resonance. Now first I'll write some resonance structures, then you will become very clear how the displacement of pi electrons or lone pair of electrons takes place in case of benzene and its derivatives. Okay, so now just understand, I'll write one of the resonating structures. Say for example, I'll write benzene which has three double bonds. Maybe it is having the substituent like NH2. NH2, we say it is a amino benzene or aniline. Now nitrogen has got a lone pair of electrons here. Okay, now in this case, that is aniline, the shift of lone pair of electrons and pi electrons taking place. Okay, I told you this is also a permanent effect, you have to remember. It needs a conjugate system, the alternate single and double bonds, and no doubt there is a displacement of lone pair of electrons and pi electrons. In some time it is only pi electrons, okay, but not sigma electrons. Now how the displacements can be written? I'll write resonance structures for one of the compound, and then you can easily apply for any other compound also. Now the lone pair of electrons present on the nitrogen in the NH2, it is shifted towards one of the atoms. Okay, so when that electron shifted, we can write a second resonating structure like this, the hexagonal ring. These lone pair of electrons coming here, it forms a double bond. This is NH2. Are you clear? Now once that double bond is formed, two continuous double bonds are not possible, because look at this first carbon atom in the benzene ring. It is already having a double bond here, here also double bond, here single bond. Pentavalence is not possible. So whenever the electrons from nitrogen shifts to the bond between carbon and nitrogen, the pi electrons of this double bond will be shifted on the second carbon atom. Okay, so when it is shifted there, what happens if electrons deposited on any of the atoms? It will produce a negative charge. Okay, it will produce a negative charge. Now other two double bonds remains unaffected, that will remain same. Now remember, this is a double-headed arrow we'll write representing a resonance structures. Now going to the next one, anyhow it is unstable due to the negative charge on second carbon atom, and that deposited electrons will be delocalized. So there is a deposition and delocalization taking place. This negative charge, the electron density distributed here, and again two continuous double bonds not possible. This pi electrons deposited here. So we will write a next resonating structure in which this double bond NH2 remains the same. These electrons dispersed, it forms a double bond here. These electrons deposited, it comes a negative charge. This double bond remains the same. Okay, that is a third resonating structure. Now we can write a fourth resonating structure here. you can understand easily how the displacement further possible. So this is double bond NH2 remaining same. This negative charge will be dispersed. The other double bond remains same. This will be distributed, means it comes a double bond here. The two double bonds not possible. This will be deposited. So it produces a negative charge on the next carbon atom. There is a sixth carbon atom. Okay. Now finally, we can write a last resonating structure where these electrons getting distributed to form a bond. These electrons going back to the nitrogen. So we will write a hexagonal ring. You can understand this double bond remains same. This double bond also remains same. This electrons, pi electrons forming a double bond. Double bond becomes single bond here. Single bond NH2. The lone pair came back. Now understand the first and last structures look similar except for the double bond positions in the benzene ring. Okay. So we can represent these are the resonating structures of aniline. Now the distribution of electrons or the delocalization of electrons happen based on the nature of the substituents. Okay. Now NH2 is electron donating group. Okay. Sometimes to the benzene ring there may be electron withdrawing group or accepting group is attached, and then the phenomenon is different. But there also there is a delocalization of pi electrons. That is also resonance effect only. So try to understand, resonance effect is the displacement of pi electrons and lone pair of electrons in a conjugate system. Okay. It is a displacement of pi electrons and lone pair of electrons in a conjugate system. So benzene is one of the well-known example for conjugate system. So I took that. It is not compulsory that only aromatic compounds exhibit resonance. Even in the aliphatic compounds also resonance is possible. So now try to understand, similar to the two electronic effects what we studied, in case of resonance effect also there are two types. Depending on the nature of the substituent attached to the conjugate system, there are two types of resonance effect. As usual, you can say it is a minus R effect, negative resonance effect, and plus R effect, positive resonance effect. Okay. Now try to understand how to remember, is it a positive or negative resonance effect. Now in this case the benzene gets a negative charge, and maybe you can represent it like due to the loss of that lone pair of electron it may get a slight positive charge. So which charge comes on the substituent, that will be the type. So here NH2 being electron donating, okay, whenever it donates electron it will get a positive charge. So this is an example for plus R effect. Okay, there are other substituents which can exhibit a minus R effect also when the group is electron withdrawing. The groups like NO2, CHO, COH, any of the groups, if it is present or attached to the benzene ring, it is electron withdrawing, and when it is electron withdrawing species it will get a negative charge and then it exhibits a minus R effect. Okay, I'll write one example for minus R effect also. Before that I hope you understood what is resonance effect and what is the displacement happening in case of aniline. Are you clear? So this is easy about the plus R effect, displacement of electrons taking place where the substituent attached to benzene ring is electron donating. Clear? Okay. The next one I'll write, that is a example for minus R effect. Okay, now coming to the next example, I told you there are two types of resonance effect, and one example we already studied with case of aniline, and I told you NH2 is electron donating group there. Okay, now let me take up one more example where the substituent attached to benzene ring is electron withdrawing. Okay, so for example I'll write a benzaldehyde example where CHO group attached to benzene ring, I'll write C double bond O and H. It is benzaldehyde. Okay. Easily you can remember the substituent attached to benzene ring, if it is having a multiple bond, okay, they act as a electron withdrawing species. Generally, like you can write CN, CHO, COH, NO2, such groups are electron accepting or electron withdrawing group. Now, when CHO group attached to benzene ring like this, it acts as electron withdrawing. Now see how the displacement of electrons taking place. Now this group is electron withdrawing, means the pi electrons of this double bond shifted over this bond. So I'll write a second resonating structure, easy to understand. See, if this electron shifted here, it forms a double bond. Now the two double bonds and single bond for a carbon is not possible. Now the pi electrons of this double bond shifted over oxygen. So it becomes a CO minus. The hydrogen remains same. See the difference what happens in the benzene ring. These electrons are shifted, the other two double bonds remain same, but due to the loss of these pi electrons, there comes a positive charge on the second carbon atom. Okay, so substituent gets a negative charge, the benzene gets a positive charge. It is an example for minus R effect. Substituentally how charge bartade adu type nenpidkolli. So substituent got a negative charge here, it is a minus R effect. So now what is the next phenomena here? The positive charge on one of the carbon atoms will try to withdraw the electrons, pull the electrons from the next position. So these electrons getting shifted. So we'll write a third resonating structure in which the benzene ring, this remains same, C double bond O, now changed as single bond O minus, it is hydrogen. This positive charge pulling the electron, here comes a double bond, this double bond also remains same. Due to loss of these electrons, there comes a positive charge on this position. Okay, so further what is the displacement? You know the positive charge will pull the electron from the previous double bond. So hexagonal ring, double bond, CO minus, here a hydrogen, these electrons shifted, so here comes a double bond, the other double bond remains the same, and there comes a positive charge on the next carbon atom, that is the sixth carbon atom. So finally these electrons shifted and this will come back. So we'll write a last resonating structure in which there is a hexagonal ring. Here is a single bond C, double bond O and H, the other two double bonds remaining same and one double bond formed here. Okay, so this is one of the examples. You can write so many examples for a positive and negative resonance effect, but remember the type is based on the nature of the substituent. Only two possibility, the substituent attached to the conjugate system is electron donating or electron accepting. If it is electron donating, plus R effect, electron withdrawing, minus R effect. Okay, so that is easy about the resonance effect. So try to practice with the different derivatives of benzene, how the resonance structures can be written. One the structure try to practice with the many substituents attached to benzene ring and how the delocalization of these electrons are possible. Okay, so that is easy about the resonance effect. Are you clear? So today we discussed electromeric effect and resonance effect. Okay, that are the two more electronic effects in the fundamental aspects of reaction mechanisms in organic chemistry. Okay, thank you.